Today, we are going to discuss operations on sets. Now, let's move on to the next, which is the definition of a complement. So, the set of elements of the universal, which are not elements of set A, is called the complement of A. So, the notation that we use is that we write A to the power of C or A prime. And the way how to read this one, we have to say that the complement of set A. So mathematically, the formula for this becomes A complement is equal to universal set minus set A. Okay, according to this Venn diagram. So the shaded region in the Venn diagram on the right shows the complement of A. So this one is the shaded region. So that is now A complement or the complement of set A. So make it short, we just say A complement. Okay. So the property, let U, this is for be a universal set and A is a subset of the universal set. Okay. So number one, A union, the complement of A is equal to universal set. Number two, A intersection the complement of A is equal to empty set. And number three, the complement of the universal set is empty. Number four, the complement of the complement of A is equal to A. And number five, the complement of empty is equal to universal. Let's try this one. Let U be the universal set is equal whose elements are 3, 4, 5, 7, 8, 9, A, B. And set A whose elements are A, 3, 7, 9. So we have to write the following set. For letter A, we have so A complement or the complement of A is equal to universal set minus A. So we have the universal set, we have 3, 4, 5, 7, 8, 9, A, B minus the set A whose elements are A, 3, 7, 9. Okay, so we are going to subtract A379 from the universal set. So that is now, we have to cancel A. Because of that, we don't have B, but we have 3. We have to cancel 3. We have to cancel 7, element 7, and 9. And then, whatever the remaining elements in this universal set is what we called as the set of A complement. So let us write. So the remaining terms from this set. So we have now, this is our A prime. We have 4. Then we have 5. We also have 8. 9 is cancelled, right? And then we also A is also cancelled, so we have B. So the elements now of A complement, we have 4, 5, 8, B. Okay, so I hope you were able to follow that one. So let's try another example. For letter B, we have A union A complement. So our expected answer for this, if we're going to take a look again on the property, we have A union A complement is equal to universal. So we will prove that one by showing the answer for letter B. So we have here whose elements of A, we have A, 3, 7, 9. And we solved earlier the meaning of A complement, whose elements of A complement, we have 4, 5, 8, B. So we have union A complement, the one that we solved earlier, we have 4, 5, 8, B. So let us try to combine everything because there is union. Therefore, start with the numbers. Arrange it also the increasing order. So we have 3, then 4, 5. Next we have 7. We have 8 and 9. Then the the letters we have A, B, which is actually the value of the universal set. Okay, so we have proved that the value of A union, the complement of A is equal to universal. Okay, so next we have for letter C, we have A intersection A complement. So what do you think is the answer for that? So going back to this property, we have A intersection A complement is just equal to empty set. So let's try to show it here. Our solution for letter C, we have A intersection A complement. So A there is, we have the given whose elements are A, 3, 7, 9. Intersection from A complement whose answer a while ago we have 4, 5, 8, and B. So try to find out if there is any common between the two sets. So I cannot see that there is any common between this. So therefore, I will say empty set. And for letter D, we have the complement of A. So our expected answer there must be a set of A. Let us try to show our solution. So we have A complement. So we have here the complement of the complement of A. If we are going to show our solution, therefore this can be universal set minus A complement. The complement of the complement. Our answer must be A. We will try if that is correct. So we have the universal set. We have 3, 4, 5, 7, 8, 9, A, B minus A complement we have here. We have 4, 5, 8. So if you're going to subtract, going to cancel this. So we can cancel 4 because 4 is found here. We also have 5. We have 5. We have 8 will be canceled. Cancelled. B is also cancelled. So what's the remaining elements? So let us write the remaining elements. We have 3, 7, 9, A. Okay, so compare this one to this set A. So set A here is A, we have A, 3, 3, 7, 7, 9, 9. Therefore, it is correct to say that the complement of A is equal to the set A, which is this one. Or I could write this one as set A. So this is now the complement of A. So mathematically, this is what I use my equation. Okay, so let's move on to the other definition. So the set of elements that are in A but not in B is called the difference of sets A and B. So we write A minus B or A slash B, but how to read that one? We will say that A difference B. So from now on, I will not call that one as A minus B or A slash B, but instead I will say now A difference B. So take note of the notation. Some books are using A minus B, or some other books also using A slash B. So whichever I'm using, I'm referring to the difference. Okay, looking at this Venn diagram, the green shaded part here is for the value of A difference B. And we know that this is for the universal set, and then this is the everything of this is for the set A, and this one is for set B. So this part, the shaded part here, is for A minus B. And then on the other side, if I'm going to do the reverse, if this side will be shaded, then this is for B minus A. So there are possible cases for the difference of two sets. So this is just this one A difference B is similar to that. Okay. And then this green shaded part is for B minus A. So actually, this white one here is for the A intersection B. All right. And if we have this kind of a Venn diagram wherein B is inside the set A, so does the orange part here is for A difference B, okay? And wherein B difference A is empty in this Venn diagram. So we have another one. As you can see, there's no intersection between the two sets A and B. So we have here A difference B is just equal to A, and B difference A is equal to B. Example that can be applied in these sets of difference. We have if A is a set whose elements are 4, 7, 10, 13, 16, 19, and 22. Set B, whose elements are 5, 9, 13, 17, 20. Set C, whose elements are 3, 5, 7, 9, 11, 13, 15, 17. And set D, whose elements are 6, 11, 16, 21. Then find the following. So I guess you can easily follow on this one because a while ago before I discussed difference, I already started using the symbol of minus or difference using the complement. So the idea there is almost the same but not including the universal set. Okay, for A difference C, so I will write set A whose elements now are 4, 7, 10, 13, 16, 19, 22. So difference the set C, which is 3, 5, 7, 9, 11, 13, 15, 17. So the idea here is that we are going to cancel out the elements of set C from set A. So I will use the cancellation so that the remaining elements will be the answer for A difference C. So I'll start first with 3. So I don't have 3 here. I have 5 on set C, but I don't have 5 on set A, so I have nothing to cancel yet. What about 7? So 7 is present on set A, so therefore I can cancel that. 9, we don't have 9. We don't have 11 too. 13, we have 13 and 13. So we have 15, we don't have 15 here, nothing to be canceled, as well as 17, so nothing to be canceled. So therefore, the answers here will be the remaining elements from set A. So we have A difference C, or sometimes we could say that minuend minus subtrahend. So the remaining terms there will be the terms that is not canceled in the set A. So we have now 4, 10, we have 16, 19, and 22. Okay, that is now for A difference C. What about D difference A? So our D is, we have 6, 11, 16, 21, minus set A we have 4, 7, 10, 13, 16, 19, 22. So I'll start with 4, so I have nothing to be canceled with here. 4, 7 is not found here in the set D. We have 10 is not also present in set D. So 13 we cannot. 16. So we can cancel 16. So that's one and this one. So that's the only thing that we can cancel. So therefore, D difference A, whose elements now are 6, 11, and 21. Okay? And next is for D difference B. We have D is, we have 6, 11, 16, 21. So subtract by set of B. We have 5, 9, 13, 17, 20. So 5 is not present here. 9 is not present on set D. 13 is not also present in set D. 17 is not present. And 20 is not found in set D. So therefore, we did not cancel anything from set D. So therefore, our D difference B will be set D, whose elements are 6, 11, 16, 21. All right. So that's the answer now. We have D difference B is actually, since we don't have any common between the two, we can cancel something from set B to the set D. So since there we cannot cancel anything from set D, therefore the answer for this for D difference B is just set D, whose elements are 6, 11, 16, and 21. Next we have letter D, we have A difference D. So I will write here A difference D. We have A whose elements are 4, 7, 10, 13, 16, 19, 22. Difference D whose set D is 6, 11, 16, 21. So try to look at here on set D and then compare it to set A. 6 is not found in set A. 11 also is not. 16 can be found in set A. Therefore, we're going to cancel this one. And 21 is not found on set A. Therefore, A difference D, whose elements now we have 4, 7, 10, 13, 19, and 22. Next, we have for letter E, we have set B whose elements are 5, 9, 13, 17, and 20. So my difference, the set C, we have 3, 5, 7, 9, 11, 13, 15, 17. So let's start now with canceling 5 because I can see 5 and 5 is common. We also have 9 and 9. About 13? So we have 13, 13. 17, we can also cancel 17 and 17. So what are the remaining elements in set B? So the answer now for B difference C, the remaining element is only 20. So we have B difference C whose set is just an element of 20. Now next is C difference D. So our C again is I will write 3, 5, 7, 9, 11, 13, 15, 17. Difference D, whose set D is we have 6, 11, 16, and 21. So can we cancel 3? No, because we don't have 3 here. About 5, we don't have also 5 on this set. 7, we don't have. 9, we can cancel 9. 11, we can cancel 11. So this can be canceled 11. We cannot cancel 13. We cannot cancel also 15 because we cannot found 13 and 15 as well as 17 is not also found on set D. So therefore, our answer for C difference D are the elements remaining on the set C. We have 3, 5, 7, 9, 13, 15, and 17. This is just a continuation of this problem. So this is number 3 and I also have number 3. So let's move on to letter G. So for letter G, we have B difference A. Let's try to answer. We have B difference A. We have 5, 9, 13, 17, 20. Difference A, we have 4, 7, 10, 13, 16, 19, 22. Now let's try to cancel. So 5 cannot be canceled because we don't have 5 here. 9 also. 13 can be canceled because it's common. Is 17 and 20 cannot be canceled. Okay, that's the only element that we can cancel is only 13. So therefore, we have B difference A whose elements are 5, 9, 17, 20. For B difference D, we have B again, we have 5, 9, 13, 17, 20. Difference D, we have 6, 11, 16, 21. So 5 cannot be cancelled. 9 also cannot be cancelled. 13, we cannot cancel 13. There's no common. 17 and 20. So there's no common between the two sets. Therefore, the answer should be the set of B, which is now 5, 9, 13, 17, 20, or simply write set B. For D difference C, we have our D is 6, 11, 16, 21. So difference C, we have 3, 5, 7, 9, 11, 13, 15, 17. So we have now, can we cancel 6? No, we can't. So 11 can be canceled. How about 16 and 21? So cannot be. So the only thing that we can cancel is 11. So therefore, we have the answer for D difference series. We have 6, 16, and 21. I guess that would be enough. So the other letters that can be for your exercises if you want to. All right. So let's move on to the next slide. So we have here, let's discuss on the properties. This must be written above, but I forgot to do it. But anyway, so we have the property of difference. We have A difference B is not equal to B difference A. Okay, take note for that. Number 2, A difference empty is equal to A. Number 3, the quantity of A difference B intersection B difference A is empty. Number 4, A difference A is empty. Number 5, A difference B is just equal to A intersection B complement. And number 6, we have if A is a subset of B, then A difference B equals empty. So the next rule here is what we called as the Demorgan's laws. Okay, or Demorgan's law. So if A and B are two sets, then the complement of A union B is equal to A complement intersection B complement. And the complement of A intersection B is equal to the complement of A union the complement of B. So let's try to consider this example. So we have to let the universal set whose elements are A, B, C, 1 up to 9. Set A whose elements are A, B, C, 1, 2, 3. set B whose elements are 1, 2, 3, 4, 5, and set C whose elements are 2, 3, 4, and 6. Now, let's try to answer the following. A difference, B complement. So, since I don't have yet the B complement, I will solve first B complement. So, shall we say here, a B complement can be written as universal set minus B. So the universal set is this one. So it's so long, so I will not write anymore. I guess my examples is enough for that, the one that I discussed earlier. And then subtracted by, we have difference B. So we have 1, 2, 3, 4, 5. So I will just cancel here the 1, 2, 3, 4, 5 because that's the elements found in set B. So therefore, B complement now are the elements of A, B, C. We also have 6, 7, 8, 9. So this is the answer for B complement. So therefore, I will write here now A difference B complement. So our A is A, B, C, then 1, 2, 3. So B complement is this one. So we have whose elements are A, B, C, 6, 7, 8, 9. So can we cancel A, B, and C? Yes. So this one will be canceled, canceled, and then the remaining elements now in set A is 1, 2, 3. So therefore, that's our answer now. We have A difference B complement whose elements now is 1, 2, 3. All right. Now for A difference B union C, so we don't have B union C yet, so I will just use this space as my scratch. So we have B union C. So let's combine everything for B and C, this one. So we can see by inspection, we can write now 1, 2, 3, 4, 5. Then C is 2, 3, 4 is already there. So therefore, I'll just write 6 to complete the answer for B union C. So I will write it here now. So set A whose elements are A, B, C, 1, 2, 3 minus the set of B union C which is now 1, 2, 3, 4, 5, 6. So the difference that we can cancel 1, 2, 3. So therefore, the remaining elements for set A is whose elements are A, B, and C. All right. So this one now, we have the complement of A intersection B. So we have A intersection B. So the complement of that, but we don't have yet A intersection B. So let us solve first for A intersection B. We have A intersection B. We have, let's try to combine A and B. What is common between the two sets? This one and this one. So what is common there, or the intersection between A and B? So 1, 2, 3 is intersection, is common, right? All right, so therefore, A intersection B is just 1, 2, 3. This is the only common, 1, 2, and 3. So I will write now the complement. So to solve for the complement of that, so we have for letter C, I will write A intersection B quantity complement, whose formula for that will be the universal set minus A intersection B. So we have universal is A, B, C up, then 1 up to 9. So I can write A, B, C, 1, 2, 3, then so on until 9. And then difference A intersection B, which is now whose elements is 1, 2, 3. So we have 1, 2, 3. So we have 1, 2, 3 is cancelled, but we also have 4 up to 9 remaining elements as well as the A, B, and C. So therefore, we have the complement now of A intersection B will be whose elements are A, B, C, and then since I shortcut it here, so 1, 2, 3 is cancelled, but I still have a numbers from 4 up to 9. So 4, 5, 6, 7, 8, 9. So that's for letter C. We also have A complement union B complement. So if we're going to solve for that, the answer for this would be just the same on the complement of A intersection B. But we will try to show. According to the property, which go back, we have here the complement of A intersection B is equal to the A complement union B complement. Yes, but we will show. First, we're going to solve first for A complement. We have the complement of A or A complement is equal to the universal set minus A. So we have universal minus A is 1. So we can cancel A, B, C, and 1, 2, 3. So therefore, the remaining terms from the universal set whose elements now are 4, 5, 6, 7, 8, 9. And then we need to solve also for B complement. So I will just write here B complement. To solve for the B complement, we have to subtract from universal set and the set B. So comparing this one, 2, 3, 4, 5 can be cancelled from comparing U and B. So the remaining terms now will be, so the elements now are A, B, C. We cancel 1, 2, 3, 4, 5. So therefore we have another elements are 6, 7, 8, 9. So we have now B complement. So let's try to solve. But our expected answer would be the same as this from the complement of A intersection B. That is according to the property. So let's try. We have A complement union B complement. So A complement we have whose elements are 4, 5, 6, 7, 8, 9. Union B complement we have A, B, C, 6, 7, 8, 9. So if you're going to find the union of the two sets of their complements of each element, so let's combine everything. So we have here, I'll start now with the letters. We have A, B, C, and then we have 4, 5, 6, 7, 8, 9. 7, 8, 9. So are they the same? Let's try to compare this one with this. A, B, C, A, B, C, 4, 5, 4, 5, 6, 7, 8, 9. See, okay, so they are just the same. Okay, for the other examples such as D and E, so try to follow the other examples.